Hello ladies and gentlemen, today we're talking about section 4.3, which is we're proving triangles are congruent, and this time we're using a shortcut that we haven't learned previously. Usually to prove that two triangles are congruent, it is necessary to prove that all the corresponding sides and all the corresponding angles are congruent. Well, this postulate allows us to skip something. This postulate says if we can prove that just the corresponding sides are congruent, then we can say the triangles are. Because if the corresponding sides are, the angles automatically will be. That's postulate 19, side, 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 congruence postulate. Since it's a postulate, it's based upon assuming this fact is true. It's not anything that's been proven. But as a brief demonstration, if I were to measure these angles, just to show you all that this does work, I've got my protractor out here. And let's say I were to measure angle A and angle R. So if I want to measure angle A, I'll take my protractor and I'll rotate it to where these line up. And I can see here that my line is crossing up here as halfway between the 40 and the 50, so at about 45 degrees. So I'll say that that is a 45-degree angle at A. If I measure angle R, if these two triangles are indeed congruent because the sides are, then angle R should also be 45, which if I measure it, rotate this, it looks like we're about halfway between the 40 and the 50, so again it is 45, so these angles are congruent. So whenever all three sides are, the angles will be congruent as well. That allows us to skip proving the angles and just proving the sides, because we know that the angles will follow. So the side, side, side congruence postulate is a great shortcut proving the two triangles are congruent. So let's do an example of using this as our shortcut. We're going to write a proof, and here the given isn't necessarily written expressly, and neither is the proof statement. They always will be. I'm not sure why this one isn't. But we're going to prove that these two triangles are congruent. That triangle LKM is congruent to triangle LNM. And we're going to use our given information, which was given in our proof over here, that KL and NL are congruent, and Km and Nm are congruent. Now, for our first step, we are going to use our given information. So, for my sake, instead of rewriting this, I'm just going to bring this down if I can. If I can't, it's going to be very, very sad. It is very, very sad. I can't bring it down. So I'm going to have to go ahead and rewrite this. That KL and NL are congruent, and Km and Nm are congruent. And that was given to us. Well, if I'm going to use side, 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 I need a third pair of corresponding sides that are congruent. In this case, these two triangles share line LM. So I can say that LM in my first triangle is congruent to LM in my second triangle. And that's our reflexive property of congruence. So I'm going to put 3 tick marks here just to show that it's my third pair of congruent sides that just happen to be overlapping or shared. And since all 3 pairs of sides of both triangles are congruent, I can conclude that the two triangles themselves are congruent. And that's using my side, side, side congruence postulate, which is my shortcut. So that's a proof example of when we might use this. Now for a different type of question, I'm only going to do the first 2. I'm not going to worry about the third one for now. But in my first problem here, we're going to decide if the congruence statement's true, explaining our reasoning. I'm going to explain this verbally and just write yes or no. In this case, it is true. Because all 3 pairs of sides, corresponding sides, are congruent. So by SSS, my 2 triangles are. Also, in my congruence statement, my corresponding parts are in the correct position. D corresponds with H, so D is first and H is first. F corresponds with J, so F is second, J is second. G corresponds with K, G, and then K. So my congruence statement is also accurate because of my corresponding parts. For the second one, This one is going to be false. No. Because I have one pair of sides that are not congruent. I have to have all three pairs of sides, side, 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 congruent for these two triangles to be congruent. So that's going to be no, because I have the fact that AB is not congruent to CD. It's a D there. Kind of got cut off. So again, you should have some sort of explanation that I just verbalized, and this is kind of an abbreviated version of what I would be looking for. And lastly, just to briefly introduce this, if you are trying to find if two triangles are congruent in the coordinate plane, we can use that by side, side, side using our distance formula. For example, if I were to find the lengths of these three sides, if I counted here, these would be 4. If I counted here, this was 3. This would be 4. And if I use my distance formula for PR, I would find out that this is 5. To find which one of these 4 triangles are congruent, I have to use my distance formula to find out which one has side lengths of 3, 4, and 5. Well, it might be easier to graph it because sometimes if you graph it, you'll see that you can just count instead of having to use your distance formula. For example, the first one, I'm at -1, 1, -1, 5, 2, 3, 4, 5, and -4, 5, 1, 2, 3, 4, and then up at 5. So I can count these and see if they're going to be congruent. Because fortunately, I have a horizontal and a vertical line. Well, if I count here, I have 3 units. If I count here, I have 4 units. And if I were to take the time, which I won't for the sake of these notes, keeping them short, if I use my distance formula here, I'd end up with 5. So these two triangles would be congruent. So it would be A. And since A is my correct answer, I didn't have to worry about checking B, C, or D. So again, you'd have to use your distance formula and or count to find out if all 3 pairs of corresponding sides are congruent. That's a brief overview of section 4.3. Hopefully it's helpful and hopefully you're feeling confident in the material.